Hey Mosby Wood 6th graders, I'm Matt Haberlin, Mrs. Haberlin's son, and I'm a mechanical engineer. When I graduated from college, I spent 2 years working at NASA's Jet Propulsion Laboratory on Curiosity, the Mars rover, and now I'm at MIT working on my PhD in robot design. So I just saw that Channel 21 video about your design studio, and I have to admit, I wish I had the chance to do some of those things in elementary school. In fact, the first time I learned some of those shading techniques for drawing 3D pictures, it was my first year here at MIT in graduate school. I also think that some of the things that you're learning about combining form and function are really important in science and engineering. And so I thought that I'd show you a few examples from the things that we're working on here at my lab. This here is our lab's cheetah robot. Our lab thinks that legs are going to be better someday at making robots travel across rough terrain, even better than wheels. And so this here is our way of exploring that idea.
By making the cardboard robots, you're developing some important skills in visual thinking and spatial reasoning. For example, our cheetah has these motors, and the designer had to pack a lot of different parts together in a very, very small volume. So visualizing how it all fit together in a given space, that was one of the hardest parts. On your robots, you're also seeing how different pieces, sometimes made out of different materials even, are used for different jobs. It looked to me like most of your structures are made out of cardboard, and your joints appear to be made out of wooden rods. So on our lab's cheetah robot, the legs are made out of plastic, and the joints are made out of metal tubes. Sometimes you can even use the same material to perform several jobs, and just use the shapes and sizes to implement a different function. So this here is a prototype for a ratchet mechanism that lets one piece of plastic rotate in one direction, but not in the other direction. Another important thing that's mentioned in an article that my mom forwarded to me is fine manipulation skills. So sometimes robot parts can be small and difficult to fit together, so it's essential to be able to work with your hands if you want to make a robot. At the Jet Propulsion Laboratory, it was terrific when I had the chance to work with talented technicians to assemble the hardware I designed, because sometimes the parts were tricky to get just right. Finally, I think it's great that you're working with cardboard and foam. These really are the materials of choice when we make what we call sketch models. This here is a sketch model of a piano alarm clock that we use to explore the size and shape of a product that we're trying to design in one of my classes. Here's the prototype of the piano alarm clock. So the story is that every year at MIT, undergraduate students have an event where they throw a piano off the roof of a dorm. So to capture that idea in a product, this alarm clock takes the form of a piano, but its function is to break into many pieces and sound an alarm in the morning. In order to turn it off, you have to be awake enough to put it back together by correctly matching the piano legs with the changing colored lights.
So it was great to see what you're up to, and it looks to me like you're learning a lot that's very important in science and engineering. So keep up the great work.